messed up. Thank you. Email plan. Oh, doğası ne yani? Oraya ne medin? Okay. So ni dia pun okay dah. Don't worry now. You find a limited there. That's the thing. I will be also here. Yeah, so that side of the world. Once everyone is here, then. we did something very specific. Yesterday? No. We had presentations in order to present them fully. Yeah, just slideshow from the unit. It is always slow. Yeah. To go there. So now it is okay. You have asthma? Yeah. Yes, it's chemical. Tanker. Yeah. That's why I don't want new generation to be spending long time. I mean, it's tanker. I rather send them on the gas carrier. That's it. You're like, they're gonna be loaded. My God. That's why still 23 and a half years. I was blue-eyed captain, blue-eyed man. But I think working for Telecom also has played a vital role on people's health. Down. I was very energetic. My father is also now. Yeah, we'll discuss that.
Okay. Can you just give me this over there? My presentation, please.
Yeah.
All right. Let them see here and then start recording. There is a bit of lag in transmission. Okay. So, can you send a message that they are hearing us? You see the screen now? Welcome back, folks, to our another session for the simulation and the presentation. First, the session will give you some presentation about the handling of LNG and the life cycle of LNG. We are assuming that our ship is a new ship which is either coming out brand new from the shore, or we are going to go through the full cycle of the life cycle of a ship, either from one dry dock to other dry dock, or from a new ship to the dry dock. So whatever happens in between that will be we are going to deliver you, and you are going to learn in different sessions. First, we are going to talk about the the procedures in theory, and then you are going to do the procedures yourself in on the simulator. So let's press on. LNG bunkering is the transportation of liquefied natural gas at a cryogenic temperature of -162 degree or -163 degree to your vessel, to either a bunker barge or a vessel. So there are multiple things involved during this thing. The storage tanks, which will have a storage facility of LNG, the liquefaction plant, the tanker itself, if it is bunkered by the tank, and of course the vessel itself. That vessel could either be a vessel carrying LNG as the cargo, or the vessel carrying LNG as the bunker or as the fuel. So this is what you are going to load, which is coming out of a well stream. The well could be at sea. The source could be anywhere. It could be any form of gas coming out from ground. And of course, that gas which comes out of ground has got everything in it. It has got mercury in it, got cyanide in it, it has other minerals in it, and in addition, other gases and the moisture. So that whatever you get from there need to be treated or processed. So the key thing what we first do is we'll do the condensate removal. And during the condensate removal, we will remove the water from there, and we also remove the other type of gases, means ethane, propane, butane, and of course the other heavier hydrocarbons if they are present in the well stream or in the gases. We will also do the acid gas removal because of course it is coming from the earth, so it could be sulfur dioxide there. We will also do the mercury removals or other sedimentation removal or other minerals removal, and of course we want to do the dehydration. So technically after that we will remove the other gases, NGL. NGL consists of other type of gases other than. What we are technically interested is in the methane, pure methane, as pure as possible. So we'll bring that methane, folks, to our compression system. Of course, we cannot compress the LNG and transport it. We can, but the volume advantage we will get is the 270 times. We compress the LNG to 200 bar. The volume will reduce to about 270. But if we cool it, we can reduce the volume to 600 times of the volume. So technically, this is we refrigerate it for the cooling process. But normally, we do not have a refrigerator available which can bring the gas from plus 20-30 degree temperature to straight away -160 degree. So we may go through the process of cascade refrigeration. Have you heard about cascade refrigeration?
I've heard of, but
we'll explain you the cascade refrigeration later when we'll do the enthalpy diagrams. So then we have got again we'll do it in multi-stage, at least a couple of stages. We will cool, compress, and put it in the LNG tank. And of course, if we want to use it, we boil it off, uh, and we use it in our ships in the gas turbine. Then we will also have the shipment facility on and we will take that. Of course, when we have removed carbon dioxide also. Because why we are more interested in removing carbon dioxide is that carbon dioxide sublimates at -72 degree, and we do not want ice formation in our tanks. So now we come to the gas processing. This is a typical gas processing diagram which we have taken from Plant Process Equipment Company. So they are saying that raw gas is coming, condensate water removal. We put wastewater separately. We can recycle that water, and we have a condensate removal. Condensate is a byproduct which we can use for some other purpose. Then we will do acid gas removals, which could be hydrogen sulfides and other gas removals and other heavy gases removals. And then we have got desulfurization. Sulfur is one of the major contents or content in the gases or natural gas. Natural gas, we need to remove the sulfur from it because sulfur may damage the tank, and of course it will affect in the liquefaction process. And of course we want to deodorize the gas, so that is where we are removing the sulfur, because once the sulfur is removed there is no smell. That's why we say LNG has got no smell, no color. So that is what makes it no color. Yeah, on the other hand, when we are giving it to the supply chain in different countries, we normally odorize it with mercaptans. So again, once this is done, we do also the dehydration. And then we will have the dehydration gas where we will do mercury removal, and at the same time if there are other type of minerals suspended in the gas, we will remove them. Then we have got nitrogen rejection from process, and then we have got a natural gas recovery unit, and of course then we will pass it through the fraction train, which I'm going to show you a short video of how this fraction process happens. Then of course we will take the methane, butane, propane separate, and we will also get the methane separated. So of course methane, ethane, propane and butanes and pentanes are another product, or the product which has a commercial value, so we sell these gases also. So this is the same, here you are watching the same LNG cycle, gas field, simplified liquefaction, storage and transfer through the ship-shore interface to the ship bring it to port B, unloading there, storage, regasification, vaporized to LNG pipelines or whatever the consumer need, and of course the ship goes on ballast voyage and for the loading. So the same thing the bunker barge is going to do: load either from trucks or terminals, come to the ship, discharge or bunker the ship, and go in the ballast passage to the same terminal for loading another load of LNG. So we have earlier discussed what is LNG, but now we are going in the precise terminology of it. classroom, and of course my virtual learners. I want you to note down this thing. What is this? Is the definition which we have got in an IGC code. It might be in your assessment. Just so what is liquefied gas? Product having a vapor pressure exceeding 2.8 bar absolute at a temperature of 37.8 degrees centigrade. And of course, IGC code has got chapter 19, which has got the list of all these liquefied gases. So, in simple words, in a layman language, we can say liquefied gas is a gas which under atmospheric pressure and ambient temperature, it can only exist as gas. So means if we fill bucket of gas with and the moment we open the lid, it will convert back to its natural position, which is gas. So now here you will be able to see various LNGs or various gases have different identity. Please, there is a slight correction. Various gases have different identification. Methane has got this CH4. And now, we are not talking about the other gases. We are interested morely in methane. So, Ras Laffan, 90.8% methane. And then Das Island has got 84.5% of methane. You may have heard, folks, the methane number. The quality of LNG varies a lot. And as a bunker, the ship owners may want to have the purest form of LNG because they are the one who are consuming it. And if the methane number is not right there, and there are so many impurities, then the combustion process in the engine is not right. So engineers, do you agree? Yeah, methane number is the most important thing. And of course, the lesser the other gases, the better, because in the combustion process, other gases will ignite first, and it will not let the piston come on. And finally, we will have the engine knocking, and also we will not be able to control the knocks properly. And of course, there may be some unburned gases going to the environment, which is again creating a problem of VOCs. So we do not want the VOCs and the other thing. So here you can see Ras Laffan. There are some examples. 90.8, over 90% of methane is there. 6.3% ethane is there. 2.49 propane is there, and of course butane, isobutane, pentene, isopropane, and of course nitrogen. So that varies. Can you see there are different percentages? And because this is an iso element or iso molecule, most of the time we try to remove them as much as we can, but sometimes it is still. So these creates problem in our combustion. Now, the molecular weight, that is, when we will do the calculation, you will understand the molecular weight plays an important role in it. So, molecular weight 17.88 means more heavy comparatively. 18.56. Why? Because methane is the one which is the lightest element. Here it is 6.33% ethane, but here ethane is 12.9%. So that ethane is a contributory factor of the total average molecular weight. And of course, the boiling point. That's why you may see when I'm talking to you or when I'm giving you lectures or explaining you, sometime I'm referring minus 161, sometime minus 162, the gas. Though the purest form of gas, on average, it is about 161 or 162, depending on the density. Now here you will see the density also, the difference in densities. Graslöfen has got a 461.8 and Das Island 456.9 or 459.
Which place has got the purest form of energy, the cleanest?
No, we cannot say. Again, it is depending on the plant. How good are the plants? How well they are maintained? As a rule of thumb, we can say wherever there is a sweet crude, there is a better quality LNG or natural gas. So, and of course, it is our plant which makes it better and better. So, we cannot say that XYZ country has got the best at the moment. The more purified we it, we can do it. But mind that we can do almost close to 100% of purification. But remember, the purification is the cost. And if the buyer is not willing to pay the cost and it was looking for a cheapest stuff, then of course he will have to get it with the impurities. This is just the simple economics of the system. If you want the cleanest LNG, you will have to pay the price.
So that means isobutane or pentane, they are cleaner.
No. If we have tried here, can you see isopentene has been removed from it altogether? Most is this because iso is not a good idea to be there. And here, Graslöfen has got just 0.02%. Another has also removed pentene. This is what they are hydrates. And then we have got here also almost zero. What we are more interested in is the density. Here, on average, we say that the density is 0.46, but it could be 4748, and the heavier it gets, then means there are more impurities. Impurities in it. Now, it is the value of energy in it. Of course, we measure it kilojoules per kilogram. So Graslöfen has got 54.414, 54.0131 and 54.090 is a standard. So this we have set as an industry standard. 000, 1.2 butane is acceptable, 2.16 propane and 6.32 is acceptable. If the refinery is within these parameters, it is said to be, it is okay. That is why we are getting this figure of minus 162 on average. But again, it is minus 161. So now the thing to remember is what is the density. This is now we are coming, because I will refer during my lecture different tanks, because we are going to experience the membrane tank and the spherical tanks and pressure tank. Let's talk about the tanks a little. Type A is the prismatic tank, adjustable to hull shape, full secondary barrier. I'm going to show you a short video that is a full secondary barrier, which is just 0.7 bar gauge, and the good thing is it is space efficient, but it has got a very thin tank size, which is ranging from 0.7 to 1.4 millimeter. So that is our membrane tank, MK3, and these are the one, the GTT models are the membrane models, and they are of course high cost. Then we have got a prismatic tank, adjustable to hull shape and practical, space efficient, but they cannot sustain lot of pressure. I'm going to let you have an experience on two different types of membrane vessels, which are two different vessels, but again they are high cost and they cannot sustain any pressure. So on a bunker barge, so far the industry is using the type C tank, which are pressure vessels. Either they are cylindrical or dished end, means bullet type tanks. They can sustain the pressure for over 2 bar, allows pressure increase, simple fuel system, little maintenance, easy installation, lower cost. But the negative problem here is that it occupies a lot of space. You have seen on the Viking graves when I have shown you that it is occupying a lot of space on the deck. And the second thing is that they are themselves heavy. Let's come to the type B tank, which is a spherical tank, but it has got a partial secondary barrier. Remember, full secondary barrier, partial secondary barrier, but is still prismatic tank. Then we have got spherical tank with partial secondary. So the LNG carriers which we were working yesterday has the secondary barrier, and the secondary barrier is technically the drip trays, and this is where you are putting in the cargo. Reliably proven in LNG carriers. Most of the earlier LNG carriers, MoS Rosenberg models were spherical type LNG carriers. So boil off gas handling, more complex fuel system required, and again it can allow a bit of increase of pressure, but different models have got different allowance. Can even go to 7 bar. Any question with type? So most of the pressure vessel which we see on the LNG carrier, we say it is type B vessel, type C vessel. But it does not mean that on a bunkering barge we cannot have a type A vessel. Type A has the good thing about the space efficiency. So we can, some of the new build bunker barge are going on this concept of type B, which is prismatic tank, adjustable to hull shape, and have a partial secondary barrier rather than a full secondary. So I hope you got this thing. So containment system, what IGC code classify it, IGC code, we have got independent tanks, totally free, pressure less than 700 millibar, full secondary barrier, type A. Pressure again, type B, 700 bars, partial secondary barrier, type C, pressure maybe over 2 bar, no secondary barrier. This is the good thing about these bullet tanks. We can place them in on the deck, we can place them on inside the hull, and they do not want any. Then we have got other type of tanks which are the membrane tanks, where in the membrane tanks, we have got, they cannot sustain a pressure of anything, high pressure, but they have got a full secondary barrier. Means if your primary barrier leaks or tank leaks, the secondary barrier will act as a full tank. We have got multiple models in it. NO96 is a very popular model which we have on in the simulator, which you will work on. You will also work on MK3 model and CS1 type tanks. So all this experience you are having now here in the simulator. So secondary barrier purpose is contain leakage and prevent lowering temperature of ship structure. Must contain leakage for 15 days. So means if your primary barrier has leaked, the secondary barrier will act as a tank. Of course, it is not an ideal situation because you are now very close to the hull of the ship, but it must be able to contain the leakage for 15 days. Means it is a tank inside a tank. Failure of a primary must not affect the secondary barrier. Means they should have some kind of buffer zone between them. So, and capable of periodically checked for effectiveness. Means they should be able to do some kind of pressure test. Folks, please feel free to ask me questions. Stop me if need be. Our virtual learners, can you please type the message down, and as soon as I'll see the message, or my colleagues will see the message here, they will reply your answer, or we will reply your answer. So this is the graphical presentation of it. This is your tank, the primary barrier. The liquid is filled in it, and this is your primary barrier. Then you have got an insulation space, and then you have got the secondary barrier. This is your whole tank. So if watch it again. If accidentally the leakage happened anywhere during the tank, the primary barrier, the secondary, the space between the primary barrier and secondary barrier will be filled, and of course there is excuse me, it is now the outer skin or the secondary barrier is acting as the second containment system for this, and then of course there is an insulation space. So still the tank is not really, the cargo is not really damaging the hull. There is still some insulation left in between the cargo, and of course in this condition we will have to be going to the port of refuge wherever we are going to discharge. When we talk about the emergencies, preferably on the last day, we will talk to you about the jettisoning of the cargo. So again, the theory in detail. Type A. Independent tanks designed using recognized standard of classical ship structures, analysis and shipbuilding practice. Prismatic tank adjustable to hull shape, full secondary. This is mostly the prismatic tanks and full secondary barrier. MK3 and other models of CS1 are there. Type B is an independent tank and designed using model test and refined analytical tool analysis method to determine stress levels and fatigue life. Prismatic tank adjustable to hull shape, practical secondary. Type C tank are independent tanks and designed using recognized pressure vessels, codes and standard. Pressure vessels could be cylindrical with dish, and we normally refer them as the bullet tanks. Or they can be in any shape, but mostly they are cylindrical with dishes end. These are some pictures of um, those tanks, and you can see these are placed on the bunker barge. The dome, of course, this is the original tank, then the first layer of insulation, the second layer of insulation, and these are the physical contact points with the ship itself. So it could be, this is a small vessel which can be used as a bunker barge, and of course you may notice that there is no secondary back. The tanks, the insulation around it, and just the mounting on it. So, but because these tanks are designed or made with a very heavy, good quality stainless steel, and they can sustain very significantly high pressures. So, and if they are sustainable to this pressures, then we can have another method of discharging, which is technically just pressurizing these tanks so the liquid can go out. Like you may have noticed that if you have a straw in a Tetra Pak, you blow the air into it, the liquid will automatically come into your mouth. So very simple process. So these are the type C tanks. Type C tank, earlier on, we were always looking them in a horizontal form. But in recent manufacturing of different ships, these tanks are installed in the vertical position. Even on some naval ships, I'm aware of, that they are fitted in the vertical position. So they could be fitted in the middle, and even multiple tanks can be fitted on it, or it could be just a simple tank with at the end the small LNG pack to manage the gas. So this is how it is fitted in different position, but again it is the type C tank. So far we have seen more of type C tanks on the vessels who are using the LNG as marine fuel, but we are seeing now Mark III or membrane tanks on some vessels design. But of course, for an LNG ready ships, this could be one of the options.
Yeah. Are there a lot of LNG propelled ships coming in?
Yes, there are. Even in fact, just last week there is a very huge container vessel which is only propelled by LNG is launched. Many of the ship owners are already converting their vessels to LNG, and there are because the prices of oil has fallen down, so many ship owners have chosen the scrubber option for ECA areas, because the ship which does not have a very long life remaining means they are going to graveyard or scrapyard after a few years time, so there is no point conversion of a very expensive stainless steel tank or aluminum tanks. So it is better to just get it changed. So to scrubbers. So they are using scrubbers. Some new build ships, the owners are still using low sulfur fuels. You may heard about low sulfur diesel oil, and they are using that in ECA areas, and in ocean they are still using the heavy fuel oil.
Now recently, what has happened? They are only using low sulfur MG.
That is good, because the prices are low. The prices are not going to be low forever, of course. They will have their peaks and troughs. So if the prices will go up, then of course the ship owners might consider putting the LNG packs into their ships, but they have already put the dual fuel engines into their ships, and the only thing they will have to do a small conversion. Many naval architects are designing the ships which have the LNG space, tanks space available. Module 1 of this project has LNG design, and it was very well covered by our Strathclyde colleagues. And if you want, you can go on to the on the MoS Way, and you will be able to get all that information about the design. Because since this I'm covering more operations, so I'm not going too much in the design. But unless you understand the design, you cannot operate it. So you will get different types of ships, or you are getting different types of ships. If you do not understand what you are you driving a Ferrari car, or you are driving a truck, or you are driving a cheap economical car of a very small size, then you will not really able to handle it properly. That's why it is very important to understand. So type C10, we are now more focused on type C10 because this is what we are witnessing in different ships. So actually this is what we are witnessing in many ships. So this particular one. So let's talk about their pros and cons. Cons is they are heavy. Yes, if you are putting heavy steel plate, they become heavy. Mark III or membrane tank could be only 0.7 millimeter or 1.4 millimeter thick, So heavier vessel or 2 millimeter. Heavier vessel are deeper draft, waste of space around the tank. That is a problem. Lower filling limits due to high relief valve setting. And of course, pros, no secondary barrier. You don't need a tank within the tank. No partial loading, okay. And of course, pressure build up possible. Construction separate to the vessel means these vessels. Let me tell you one more thing, that normally on membrane tank, because of the waffle membrane, there is not, and there are certain construction where we have some problem of sloshing. But that is now controlled in the new design. So, but normally we don't load prismatic tanks partially. We load it more or less full, to the maximum loading capacity. But these tanks, you can do partial loading, means a barge can go to one ship, supply half bunker to one ship, and half of its load to another ship. So construction separate the vessel to the vessel, and it is potentially easy to install. Make it outside in the workshop, bring it in here and install it on the ship. And that is what the LNG ready ships are going to do. That whenever fuel prices are not right for them, they will just buy the tanks, install it, but the infrastructure is already there, the fuel engine. So it is like just installing a bunker tank. At the moment, they are using that space for earning capacity. Your question.
So this MGO has got a problem. And when we are at the ECA regions, we change over. So there's a lot of mechanical problem with the MGO, like the fuel pumps or
purifiers. You need to purify it. You need to desediment it. You need to settle it. You need to heat it.
And the engines, the fuel pumps, they get seized, or the pistons get seized. So is there a problem with the LNG also?
For the project, when we were doing the different activities, we were involved in cross-fertilization. We were lucky that we went to vessel which is Viking Grace, and we have witnessed the engine room. And they were proud of their engine room, and now I am also proud of there in the room, that you can have your dinner in the engine room. It is as clean. And I have learned from our colleagues who are specialists in Mozilla and other, and when they open the engine, it is technically carbon free. On the first day, if you recall, I've shown you a video where the carbon, virtually the LNG burns without any carbon residue. So carbon residue is not there. So engine technically the maintenance life is long. Yes, of course there are some lubrication issues and etc. That is secondary problems. But technically the engine has got a larger life, not like MGO where cleaning it again. Construction separate to the vessel, potentially easy to install, potentially easy to operate, and of course it can handle the warmer cargoes. You do not need to have it on always -163. If the bunker barge is going outside, the temperature may increase and it can sustain the pressure. Whatever vaporization has happened, it will still remain there in the tank. So good for it. Now we are talking about the type B bunker tanks. Technically, type B bunker tanks could be, partial secondary barrier or the full, partial secondary barrier or full secondary. So this is, you can see here, this is your main engine room area. This is your generator. Both can run by the LNG. This is on this particular ship. This is an actual ship picture. This is where they have used certain container space for the tank, and of course they have a very little heavy fuel oil tank also here, and then they have bunkering system here. I'll show you. In fact, I've shown you the picture in my earlier presentation for this vessel doing the bunkering here, but I'll show you again.
So that means LNG bunker tank is bigger, huge, and the HFO fuel tank is small.
Yes, because of the density and the amount of energy, the BTU, because LNG bunker tank always require a larger volume as compared to other bunker tanks, So that is the membrane tank which I was referring to you. What it has got the primary membrane, which is a waffle membrane, and these are the things which create the sloshing problems. Then underneath it there is an you can see the hardwood, and then or plywood. Then of course we have got top plywood, primary insulation, and then secondary membrane, composite secondary membrane, which act as a second tank. And then we have got secondary insulation layer, and of course second layer of plywood, and then finally of course that is your tank. So that is how it is taken. Plywood, the plywood, insulation, plywood, secondary barrier, insulation, primary barrier, and of course and of course this is how we are going to show you a video, which is and of course this is how we are managing this. So let's go to the NO96 model, and because it has straight lines, straight plates, no waffle membrane, and this is how it is you know, embedded in between the plywood, and the steel. So technically this is what which goes inside, and then we put this sheet. I will show you a video of the construction of these. This is another model of NO96. Did you notice that NO96 does not have the knotted part of it? It is a straight line of stainless steel. This is the version of GTT CS1 containment system, which has got the secondary membrane with glass cloth, aluminum foil, a bonding compound, another glass cloth, and another bonding compound. Okay, so that is all. This was attached itself. And the good thing is that you can paste it. You can put patches in it, and it will remain as a good tank. So this is where this barrier is gone. Inner hull, polyurethane foam, flexible triplex, and of course the tank lining itself. So you can see the construction is more or less flush kind of thing, except the joint line, which has got different. So LNG bunker vessel, although we have seen more of the cylinder type, but it does not mean that we are not constructing NO96 Mark III CS1 model or membrane tank. A lot of new vessels are ordered with this technology, because that is also a technology which is time proven. So
one more doubt. Then that means NG bunkering is much more different than the HFO bunkering. So it will require a very specialized team of crew to do it.
Just recently, when IGF code in June was given, IGF code has also given the training standards. They have given the amendments, or they have to SOLAS, which is addressing all the safety matter, construction, etc. It is also addressing the STC. At the moment, the SGMF is Society for Gas and Marine Fuel is writing the training standards, but their working tragedy is that you have 4 levels of training. The one who are nearly involved in it, or assisting in it. So they have a layer of assist, do, manage. So there are 3 layers, and then there's an additional thing which is called the support, or respond, specialist training for the response group like fire brigade, etc. So those trainings are going to be mandatory from 1st January 2017. So yes, that is in the pipeline. Every vessel which is carrying LNG as a fuel, the staff need to be trained for that as per the new IGF code, and of course the bunker vessel staff is going to be trained. Okay, any more questions? Okay, let's move on. So this is the real operation which we are going to do for full course. We are going to do the loading preparation first. Of course, loading preparation we will do as a theory part. Then we'll talk about the drying process, and you will literally do the drying on board the ship. Then we'll do the purging, gassing up, cooling down, loading, loaded passage, unloading, ballast passage, the berthing operations. Berthing operations will more be covered in module 4. That's why we'll have just leave it to the cargo only. Warming up of tanks, purging, and aeration of tank, which is also degasification. So these are the processes which we are going to do. So now whenever a new vessel is made, the first gas in it is the biggest problem. So the model which you see on the top here is the MoS Rosenberg design, and of course these are spherical tanks which are sitting to the, or which are connected to the ship through the equatorial ring and a skirt arrangement, a manifold here, and then this is a membrane tank, spherical and membrane. So even the bunker barge could be spherical or membrane. So in a membrane type arrangement, we will have to maintain the interbarrier spaces or insulation space. We'll have to do the pressure testing of the tank itself and the interbarriers. And normally the interbarrier spaces are filled up with nitrogen. So we'll fill up nitrogen in these spaces if it is required. Then you can see here on this picture, you can see that we will have to remove the debris. This is an actual tank. After repairs, correct installation of equipment. This is one of the very important tasks. If the inducer is not put in the proper fashion under the pump, cryogenic pump, then it is going to make a problem. Then we'll have to remove all the moisture or water. Of course, the physical water or floating water we can easily remove, but the moisture molecules which are suspended inside the tank, we will have to remove them in our drying process. We will do the testing of the equipment, different equipment and we will have to check all the tank furniture, means our tripod and all the things associated with it, especially the radar systems, the temperature sensors, etc. So we also check the integrity of our primary barrier by doing some kind of pressure testing. There are multiple ways of doing it. We can fill the gas in certain gases in the tank, and we can do from the gas detectors and from different color paints or chemical paints. So the legal aspect, the majority of LNG shippers and receivers have a legitimate concern over foreign bodies getting in. Even your broken hair inside a tank is not a good thing. So the main concern is the risk of valve blockage. If say an old welding rod become locked into the valve seat, then of course such occurrences are not known with the ship discharging first cargoes after new building or recently having come from the dry dock. Despite discharge time diseconomies, it is common practice to fit filters as ship's liquid manifold connection to stop any such material from entering the shore system. So this is a P&I club information which I have shared with you. So post-refit dry dock, examine the operation required after refit, examine what is to be done, and investigate why some processes are performed in certain fashion or certain way. So now we will have to do our insulation spaces, particularly in membrane tank, are just filled up with ambient air. That is not the good thing, because the ambient air has got moisture in it which will freeze. Hmm. So to prevent the flammable atmosphere in the event of leakage from primary barrier, you need to have the space or volume in between your primary barrier and secondary barrier in a non-flammable environment. And permit detection of a leak through a barrier. Of course, maintain dry atmosphere in insulation space. That is our ideal thing. We always try to maintain dry atmosphere there. And of course, prevent corrosion in installation spaces. Deter migration of leakage from primary to secondary. In particular, NO96 module, vacuum pumps evacuate the air. Vacuum, if broken with nitrogen vaporizer on board, short supply liquid could be taken and converted. MK3, smaller volume, is served with a nitrogen generator on board to remove the. So MK3 is the only, not only, is one of the model which has got nitrogen generated on board. So now we talk about the drying of and hold spaces. MoS tank, the big round one you remember. So the purpose is to reduce the corrosion of a hold space. Of course, the hold space is the area around the spherical tank, most of them. Reduce formation of ice and cold spot or ice formation. We do not want an ice anywhere, around the tank. Dry air is used as that CO2 in a inert gas will create solid dry ice. We hate CO2 in LNG carriers. Why? Because CO2, although it is one of the inert gases, but it has got a tendency of freezing, directly freezing from gas to freezing solid state within few degrees of boil-off point. Should flammability become a concern, inert gas can quickly be introduced into the tank and insulation and annular spaces. That is, annular spaces in a spherical tank and insulation space in between. Long tank. Insulation with the annular space is part of a leak protection system. Nitrogen in the annular space quickly transport leaking vapor to gas detector. That is a good thing about it, because it is you may have seen yesterday during the simulator exercises, nitrogen supply is coming, and and you can even purge it out. Any leakage liquid is directed to drip tray under the tank, because drip tray only is the secondary barrier. So now we will do that is the pre-checks before we start any operations for our. So first thing first, after cleaning the tank, we will go for drying of the tanks or removal of moisture, because these moisture molecules could become hydrates in future if they are left in the tank. So this is just a presentation given on different level, 100 meter, 40 on that. So gas hydrate, CH3, the methane hydrate is seafloor sedimentations. What it could damage the pump impellers, it could damage the pump itself, because it is like an abrasive, an ice crystal which is formed at minus 60 degree, 70 degree temperature or 0 degree temperature. If you cool it further to minus 162, it will become a solid ice crystal. And that solid ice crystal could work as an abrasive. It could sand paper, and it could be damaging. So, 100, this is just, representation on different. So the compounds formed by interaction of water and hydrocarbon in certain pressure and temperature, that crystalline substance So this is normally the formation of hydrates are more in propane and butane. The problem of hydrates is less in methane. But remember, methane does have impurities in it, or LNG does have impurities in it. So propane and butane react with water and form hydrates. Block lines, filters, pumps, reliquefaction plants can be prevented by inhibitors only in LPG carriers. Normally, we do not want to use the inhibitors, but we normally do not have too much of problems of hydrates in our normal working zone. So this is a methane molecule, CH4, a simple molecule, but it will be engulfed by the water molecule, H2O. So CH4 will be trapped in between, and these can take shapes of crystals and different thing. So it can become a solidized block, etc. Here you are witnessing the filter of a bunker barge which was supplying the bunkers. You can see the mesh, quality of mesh. You can still see outside it is very cold and there is a nice formation on it, on this one. So can you see these hydrates are blocked at the filter on there. There are multiple type of filters which are there on the bunker barge itself and on the receiving ship itself. There is a cone type filter which you insert a cone inside the line. It will have a bigger area for catching these molecules or these hydrates. This is the cone type filter, hydrates filter, and you can see now the area here is multiplied, very big area, which can be used for. Then reliquefaction plant, that is on a QFAX plant. So now the question arises. The question arises is why do we want to dry the tank?
So that there are no impurities like hydrates.
No water. And the second question is how to dry the tank? You cannot go inside the tank with your towel and keep drying it. There is nothing on the wall.
There are dryers, drying plants on that.
Yesterday I've shown you in the thing what we can do is take the environment, treat it, dry it, and give it back to the tank. Okay? So once a ship is coming out of a refit, dry dock, or a new build, it has got an air in it, which is an ambient temperature air, and of course it has got the humidity of that place, almost the same. So dry tanks to remove the moisture or condensation will freeze. From inward membrane corrosion may be caused by the IG. So we can normally try to keep the IG away from membrane tank. If we need to inert other than IG, what other thing we have available? Can you tell me? No. If we do not want to use IG, got nitrogen in it, isn't it? Nitrogen. So how
nitrogen is used for the
because nitrogen
goes only for safety.
No, it can be used for inerting because the you cannot put an hydrocarbon gas into an environment which has air in it. Otherwise, your environment will go into the flammable angle or flammable range. pass through flammable ring. So you need to create a buffer zone or buffer in between. So what you do, you remove the air. First you dry the air. You dry the air, so now there is no moisture. The first thing you are doing is removing the moisture. Dry air means preferably minus 40-degree dew point. So minus 40-degree dew point is where you will bring the dry. Now you need to inert the tank. So you will use either the dry inert gas or dry nitrogen. Of course, nitrogen is comparatively more expensive. Inert gas, you have an inert gas plant, you can generate. So you do the inerting of the tanks, whatever gas you want to. Either you want to use the flue gas. There are multiple gas, argon, krypton, nitrogen is also one of the, so whatever your pocket will allow you, or whatever system you have, because this inerting will only be required once you have got a ship coming out of refit or a dry dock, or when it's a brand new ship. If the ship is running in a normal cycle, the tanks will always have vapor in it, the gas. So there is no need of. So thank you. I hope I have answered your question. Yeah. Okay. Yeah. Please feel free. This is all about. Our virtual learners can also ask questions. I'm here for you. So how you can dry the tank? Use the IG generator delivering the dry air. And now, of course, this is what you will do in the exercise. So simply, we have another system which it is like an air conditioning unit. Have you seen an air conditioning unit in your home or somewhere? And it has always got some water dripping on the outside, and that is the water condensed from your environment in the room, because it is going through chillers or evaporator. So if you will see here, this is just the cooler. You are cooling the refrigerant. In this case, it is R22, monochlorodiafluoromethane, and that will be cooling this thing. And if you pass the gas will leave all its moisture there. And further on, you can use the demisters or silica gel or active alumina dryers. Here we have got just a conceptual plan of inert gas generator. You are burning the fossil fuel, any one of them, preferably low sulfur diesel oil. Then you scrub it, you bring and you chill it, cool it in this through this refrigeration system which I have shown you earlier. And then this chiller will not be able to remove all the water. Okay? So you will have to send it definitely to the dryers. These are the dryers. 2 batteries, I've explained you yesterday. 1 battery is regenerating or in a standby if regenerated already, and the one is active. 8 hours on average, you can use this one. 4 hours for regeneration of the other one. Once it goes on standby, they keep on switching. It can be switched earlier if you have got too much moisture in it is already filled. So this is the inert gas generator, which is technically burning the gas. The gas is burned, and air is injected and fuel oil is injected, means low sulfur fuel oil in it. And of course, once we burn it, we are scrubbing it, that gas is going out, demisting, getting demisters, then cooling plant where it is the moisture is being removed, then it is going to dryer, and from the dryer to the supply system on the deck.
Why we are cooling it again?
This is a cooling plant.
Yeah, but why we are cooling it?
To remove the to condense the water. It is to condense the water, because when we are giving it in a scrubber, this is a hot flue gas. Hot flue gas is rising, and we are putting it moisture on. Do you know the exhaust temperature of a boiler, roughly?
1200.
Yeah, hundreds of degrees. So if you put hundreds of degrees, if you put the water on 100 of degrees of gas, what will happen? You know, the diffusion of water.
And we have gas.
No, that is your inert gas generator. This is an inert gas IG plant. Where we are, can you see on the top? That is
Yeah, I'm seeing it.
yeah, that is the fuel oil, low sulfur fuel oil preferably. We are burning here. We are injecting air to burn it best. So we have, and then, of course, the flue gases are rising up. They are now here. They were very hot. Now they are getting scrubbed. Everything is scrubbed out, going out of,
Everything that we do not need.
Yeah. And then it is demisters here. But demister cannot hold all the take out all the moisture. So it goes out and we give it to the cooling plant. Cooling plant is this one here. And when the gas is passing from here, there are so many tubes in it. And every single drop or molecule of moisture will condense here on the tubes like sweating. And that is now drained. It will go out from the drain and reasonably dry gas is going out. But mind that gas may not have an ideal minus 40 degree dew point or below 40 degree dew point, 45 or more. So we need to definitely pass it through the dryers, set of dryers. So these dryers will be, dried, and you will see these are the dryers. Okay? If we have got a very good quality here, then we can bypass it, just directly. But it is better to pass through dryers, and once it is dry at the driest, and we will put it in the tank. Now here you will understand it more better, what I was talking about. Now, let's see what is the ambient temperature in Middle East, where the ship is plus 40 degrees, say 40 or 30 degrees, say 40 degrees. Watch this very carefully. 40 degrees will have about this much grams of water per cubic meter, 50 grams. Now, your scrubber, it is coming out of a scrubber at 40 degrees and it is going to cooler. So that 50 grams of water will become just 5 grams of water if we are passing it from the chiller, which is around minus 4 and minus 3 degree temperature. Did you get the idea?
Yeah.
Most of the water we are condensing in chillers. That just cool, simple your air conditioning system. We are cooling the gas and we are also drying the gas. Or I would use the word IG or air, both. Okay? Now you see the moisture has removed to 5%, but 5 gram per cubic meter. But if I would send it to tank at this point without further drying it, imagine my tank internal volume, say it is 500 cubic meter. How many grams of water crystals I will get? Say 1000. Easy mathematics. 1000 multiplied by 5, and we will have then 5 kilos of hydrates in our next minimum. That is, we don't want that. We preferably have a 0 level of hydrates. So what we will do, we will cool it down to minus 40 degree temperature. If we cool this down further to minus 40 degree temperature, can you see how much is my water content? Just 0.1 grams per cubic. So that's why we are using this. You may have seen me using this figure, minus 40 or minus 45. Ideally, minus 80. Because at minus 80 level, you have got 0.0004. But, but that will take a lot of effort. So this is the thing, that if 0.1 gram of water is in 1 cubic meter, then when we gas up the tank, because after drying the tank, we have put inert gas. We are going to put inert gas. And once we take out the inert gas, we are going to replace it with the gassing up procedure. When we gas up, we are purging out the air, the inert gas from the tank. So that even 0.1 gram per cubic meter is now going to go out. Did you get the idea? It is not going to stay in the tank. So technically, after gassing up, my tanks will be virtually water-free or moisture-free. Okay, this is what you will do on the simulator. So dew point temperature plus 40, roughly 52 gram. If we bring the temperature to 4, it will have, so just 45 gram per cubic meter are removed just by cooling the gas or passing the gas through chillers or through some dew point. Minus 40 is an ideal one. Okay? So extra sun folks on, of course, in this drying process. So how we achieve this? We are passing it through this active alumina dryer, silica gel dryer, or other type of dryer. Different manufacturers have used different technologies. So this you may not have seen ever. You can see the ice is burning like a candle.
Like we have, I don't know what we call it in English, but kapoor.
Yeah. But that is totally different. That is a solid form of hydrocarbon. That is ice itself. And because hydrocarbon stays as gas, liquid, and so that kapoor you were telling me, it is a solid form of hydrocarbon which has got more than 16 carbon atoms. 16 carbon atoms. Yeah. Because
camphor.
Yeah.
That's camphor.
Yeah. So here you see this is the methane gas and water pressure kilograms and etc. So this is the methane molecule CH4 trapped in between this H2O molecules, and yes, when you put it on fire, this is so it is an USCG source. Got it. So now at this stage we will take a break, because now we will go on the simulation mode where you will do the drying up and then we will come back and start from changing the atmospheres in the tank. So the virtual learners, we are going for a lunch break here, and then we'll come back and we'll start the simulation of membrane tank.